square and square root. Perfect square and non-perfect square root number. The square root of a number that is not a perfect square. Perfect square and non-perfect square numbers. Divide the following numbers into two groups: 2, 3, 4, 5, 20, 25, 27, 64, 81, 93 and 100. Of the above numbers, 4, 25, 64, 81, 100 are square of integer. A number which is the square of integer is called a perfect square. The numbers 2, 3, 5, 20, 27, 93 are not square of any integer. These numbers are not perfect square. Now let us see some properties of square number. Keep observing the following numbers. What are the digits in the unit place of the square numbers? All these numbers end with 0, 1, 4, 5, 6 or 9 at units place. None of these end with 2, 3, 7 or 8 at units place. Can we say that if a number ends in 0, 1, 4, 5, 6 or 9, then it must be a square number? If a number has 1 or 9 in the units place, then its square ends in 1. When a square number ends in 6, the number whose square it is will have either 4 or 6 in units place. The square root of a number that is not a perfect square. In triangle ABC, length AB is equal to 2 cm. Length BC is equal to 4 cm. Measure of angle B is equal to 90 degree. By Pythagoras theorem, length of AC square is equal to length of AB square plus length of BC square. Putting the value of AB and BC, we get the value of AC square. Hence, the square of the length of AC is equal to 20. It means that the length of segment AC is equal to square root of 20. The square root of a non-perfect square number. Consider square root 20. We take it as step 1. To find the square root of 20, we put bars on the integral part, that is 20, of the number in the usual manner, and place bars on the decimal part, that is 0, 0, 0, 0, 0, 0, 0, 0, on every pair of digits beginning with the first decimal place. Now step 2 is find the largest number whose square is less than or equal to the number under the extreme left bar, that is 20. 4 is a number whose square is less than 20. Now take 4 as the divisor and 20 as dividend. Now divide 20 by 4 and get the remainder 4. Step 3 is the remainder is 4, right? Now write the number under the next bar, that is 0, 0, to the right of this remainder to get 400. Step 4 is double the divisor and enter it with a blank on its right. Since 0 is the decimal parts, so put a decimal point in the quotient. Step 5 is, we know 84 into 4 is equal to 336. Therefore, the new digit is 4. Divide and get the remainder. Step 6. Since the remainder is 64, and write the number under the next bar, that is 00, to the right of this remainder to get 6400. Continue this process until you get the fourth decimal number. As 20 is not a perfect square, we will get more decimal places if we continue the process of finding the value of the square root. It means that this process is never ending. From the above example, square root of 20 is equal to 4.4721. In 4.4721, the dots on the right denote that the further there will be an infinite number of digits. So, square root of 20 is equal to 4.4721 and negative square root of 20 is equal to minus 4.4721. Henceforth, however, we shall only consider positive square roots. Therefore, square root of 20 is equal to 4.5. That is, approximate value up to the first decimal place. Square roots of a decimal fraction by the division method. Consider square root of 17.64. Step 1. To find the square root of a decimal number, we put bars on the integral part, that is 17, of the number in the usual manner, right? And place bars on the decimal part, that is 64, on every pair of digits beginning with the first decimal place. Step 2 is, find the largest number whose square is less than or equal to the number under the extreme left bar, that is 17. 4 is a number whose square is less than 17. Now take 4 as the divisor and 17 as dividend. Now divide 17 by 4 and get the remainder 1. Step 3 is, the remainder is 1, right? Now write the number under the next bar, that is 64, to the right of this remainder to get 164. Step 4 is, double the divisor and enter it with the blank on its right. Since 64 is the decimal part, so put a decimal point in the quotient. Step 5 is, we know that 82 into 2 is equal to 164. Therefore, the new digit is 2. Divide and get the remainder. Step 6. Since the remainder is 0 and no bar left, therefore square root of 17.64 is 4.2. Which way to move? Consider a decimal number 176.345. Put bars on both integral part and decimal part. In what way is putting bars on decimal part different from integral part? Notice, for 176, we start from the units place close to the decimal and move towards left. The first bar is over 76 and the second bar over 1. For 0.345, we start from the decimal and move towards right. First bar is over 34 and for the second bar we put 0 after 5 and make 0.3450. Summary. In this topic, we learnt how to find perfect square and non-perfect square root number. The square root of a number that is not a perfect square. So that's all in this topic, student. Till then, keep learning.